All right, welcome back to another episode of Minetest Gameplay of Sorts. Yeah, and today we're going to do something a little bit different. We are going to pull the covers back on the great and mysterious Oz, and we're going to see behind the curtain of what actually makes Minetest tick, sort of, at least in the database part. So, yeah, we're going to go over the corrupted database and how to fix it, and tips that you can hopefully use in your world. And from the last episode where I could not remember the Libre Office base and Open Office base, it uses HyperSQL. Yeah, which is very good. Java database embeddable. So Minetest uses SQLite. It's a transactional database, which is used by a lot of other different companies. It's public domain. It's been around for a long time. It's one of the most widely released or used databases in the world. And you can embed it in programs and anybody can use it. So there. It has a full line of documentation, as you'll see. And it tells you what about the corruption, which we're going to deal with. And basically, there's a lot of different things that can corrupt said database. It could be a bad hardware, power outage, something in the game conflicted. The lock file on the database didn't unlock when somebody tried writing to it. So basically what happens is, I'll show this in a second here. This is the exact backup script I'm running on my server. I will post a link to this on setting up an Ubuntu server because my DigitalOcean is an Ubuntu server. And over a year ago when I set up my server, this is how I did it. And I still run this to this day. Yeah. So we're going to close that, and we are going to go in my broken world. Now, if you look in here under my Minetest directory in my home folder, on Linux, it'll be in your home folder. You'll have to turn on view hidden files because it's a .minetest file, and then it'll have world and is like this layout here. This is going to be a long episode. So you can see here map.sqlite and map.sqlite journal. This database was interrupted. That journal, that should not be there. That is unwritten data waiting to be written in. Now this is where the ACID compliance comes back in the database. And what that is, you'll hear that term in enterprise, banking, anything that requires a transaction. A transaction is where a transaction in the sense of a database is a group of commands. It may be select blank from this table and where date equals this, or update this record. You can have a bunch of commands in one transaction which gets executed. So where you'll hear the term ACID, which means atomic, consistent, isolated, and durable. Atomic means all or nothing. The transaction either goes through or it doesn't. So the game either writes the blocks to the database, or none of the blocks in that transaction get written in there. Consistency. You can run the same query over and over again, and the database will give you back the same result. Isolated. In other words, you can't see what one transaction cannot see or interfere with another transaction. And durability. When the server goes down, if something happens, anything that's written inside the database already will still be there in that state. So If you have a major, generally in enterprise, you'll have servers, database servers where the engine is on one computer, one server, and your database files are actually on a NAS, a network access storage, or some other type of storage hardware. And so if that server up and dies, they could literally roll it out to the dumpster, bring up a new one, and whatever database engine that you're using from whatever vendor, fire it up, point it towards your database directories, your actual data, and it'll come back up in the exact same state that it was left. So that's what that means. So by no means is this going to be a very in-depth look into programming and databases. That's not what my intention on this is. I'm going to reboot up my world here, as you can see. And the reason why every once in a while I'll do this in a terminal, I'll run Minetest -- server -- whatever world that I want to boot up, because when I run everything solely on one computer on the Mac, because of the amount of mods that I use and the amount of everything else that's going on, I usually get a lot of out of memory conditions and crashes. And so what happens is, and you'll see the server just crashed. When we fix this database, and then what I'll do is I open up an instance of Minetest, and this is the client onto the server. And I have none of the out of memory issues, and it'll actually run almost as good as my DigitalOcean server. So it failed. It failed to run. Basically, after advanced trains loaded, an unhandled exception occurred. Failed to save block database images malformed. Yes. And it just says that in line 72, virtual void server thread. Now, this is over my head. Something happened. Now, you never want an unhandled exception. Now, it's kind of impossible to anticipate every kind of exception, sort of, but the program should gracefully shut down. It shouldn't hard crash. So it should give some kind of better error message, because not everybody sees or boots it up this way. And if you boot it up normally in just a client, you will never see this. It'll run for about 5 seconds and then shut down. So this is the most of the information that I could find on the debug. That's it. So we know this failed. Yay. So what we are going to do is I'm going to copy my map SQL file to my desktop. Man, I cannot. Wow. And I have a list. I have a whole bunch of database programs because I love working in database. I am a DBA. Everything from MySQL Workbench, NoSQL, Database Beaver, or dbeaver is a real good program. The dbeaver, SQL Workbench J, and DB Browser are all open source. We are going to use DB Browser because it's cool. We're going to point it towards that database. And for all you command line lovers, I will also show you this in the command line. So we go to map.sql, open that, and there's a problem with that. Wow. That's because I'm in the wrong. Oh, I should have been watching where I was going. There are no tables listed in there. Something happened to that one. So on my desktop, where is it? Come on, map. There we go. 230 megabyte file. Now we open it. Basically, there's a bunch of different components in here. What you see is the database structure. So it has a main. So SQLite databases are enclosed in like a main. You can think of it like a big, huge container. Inside that container of the database is your tables. This database has one table, blocks. It has two fields, two columns, and that is POS, which is, I believe, position, and data. Position is an integer. Data is a blob, binary large object. That just means it can be anything. It can be a picture. It can be whatever the program wants to put into there. It doesn't conform to other data types like integer, numeric, real, varchar, or variable character, text file, date time, timestamp, any, those data types will be in there. So let's see if we can actually see some data in here. We're going to browse data real quickly. And everything, like I said, it's to pull some of the mystery off of working with databases and programming. If you've ever wondered, it's kind of like owning a car. If you own a car, that doesn't mean that you're going to go in the garage, rip the engine out, and rebuild it. However, you might be interested in what's inside the engine. You're never going to take one apart, but you get to look. In what I'm doing right here, you get to look and see what's actually in here. This is a record. There's 389,108 records. Very nice. And in that table. So we are going to go back and we are going to execute some SQL. Now on the page on SQLite.org, .org, you can see the different tools and the command line shell, everything that you need to know about about this database. So we are going to type Pragma. Now, what that means is that's an extension. Every database vendor does something differently with SQL. SQL is called Standard Query Language, and it's a standard. Structured Query Language, which is a standard. In other words, all databases will have some sort of compliance when writing standard structured query language. In other words, all databases will have a select. You can update, delete. What database vendors like to do, like Microsoft SQL Server, MySQL, MariaDB. Well, MariaDB is a drop-in replacement for MySQL. MySQL is my favorite. Apache Derby, SQLite, Postgres, Oracle database. They will all have little functions or commands that are exclusive to their database. Only work on their database to give them an advantage over something else. So, and a lot of times, like rollup, SQL Server, and I cannot remember what the command was, but it was similar to rollup, and they depreciated it to go with the standard rollup. Rollup is where you'd run that at the end of your query, and it would tally up. It would aggregate your queries. If you were looking for the count of items in this field, or the sum of, or that's how that would work. So Pragma is an extension of SQLite. It means that there's going to be special commands after it. And we are going to do an integrity _ check. And in this version, you don't have to put the semicolon, but in the command line version, one does. So we're going to run that. It's going to take a few seconds. And whoa, look at that. Integrity check. Main free list 1 of 3 pages missing from overflow list. That's not good. That's corrupted. Now you will see, sometimes you'll see page something is never used. Those are unused pages, and the vacuum, those generally won't cause the database not to open. Those are just where things could have been deleted. And what happens is data in the database, it opens up a page file, and the page file is usually 1 meg, 1024 kilobytes. On that page file, it'll store a bunch of records. Now, if those records are deleted, it doesn't delete the page file. The file gets reused. So that's going off the deep end a little bit. So we know we have a problem with this. So we're going to open up another tab, and we're going to type vacuum, and I can't spell that word to save my life. We are going to run vacuum. Say yes. Now, I'm running this off of a copy. So I copied the database file to my desktop so I wouldn't harm the original file. Nobody's going to hand you a $2 million Bugatti and a can of spray paint and say, I want you to spray paint this car professionally on the first try. So nobody's going to do that. So if you had a copy and you ruin the copy, you could always go back to the original. Okay, so the vacuum command executed fine. We're going to go back to tab number 1. We're going to rerun our integrity check. And other databases will have an integrity check, check databases, analyze databases, and it'll all be a little bit different. And we're okay. It is done. So we're going to write changes and come up here, and we're going to close the database. Now, one thing I wanted to show. So what you can do, let's reopen this database here. What you can do, let's say that this vacuum command, which kind of got rid of all those nasty open page files and set everything straight. Let's say it didn't work. One other option that you have is that you can go up here, and it's a little bit different in the command line, but export. We can export to an SQL file. So I want to take this table, and I want to do this anyway. And we are going to keep file names into the insert statements. The table is blocks. We are going to export everything, and we are going to overwrite old schema. And you could do it either way. Keep old schema, create table if it doesn't exist, or overwrite schema if it does exist. And we're going to click OK. We're going to save this as blocks new to the desktop. It'll take a few seconds to export. What this is doing is it's taking all the data from the database, and it's performing a thing called a database dump. And it will take all the records and write them as SQL statements so that you can reconstruct the database in its entirety from all the good records. And the export is complete. Now, if we wanted to, we could go in here and import database from SQL file. So I'm going to show you what that looks like real quick. We're going to close this database. We're going to get out of this. We don't need this anymore. And here's my block SQL file. Open that up. And here we go. This is what I'm talking about begin transaction. And at the end of this file, I don't know if I can actually reach said file. There should be an ending. Nope. It's not going to let me do that because the file is huge. So it says begin transaction. If that table is already existing, it's going to drop it. It's called drop table. It's deleting the table. If exists, it's going to create the table called blocks, and it's going to have these 2 columns, 2 fields, position, which is an integer, not null, meaning that the data cannot be null. That field cannot be empty. You ever go to a website and it asks for your name, and you put in your name, and you don't put in your name, you just hit continue, and it says, no. You need to put in your name. This is what that is. And it's a primary key, which means position that the position will always, the primary key, whatever data is in the position will be unique. It has to be unique to be a primary key. Now this gets when you get into advanced database stuff with primary key and foreign key restraints, where you actually have tables that are connected, where data in one table will coincide with data in data in one table. Like you have an employees table and a training table, and then you can have a other related tables like address table, and because people can have more than one phone number, you're going to have a phone table, and all these tables will be linked together. And where these key constraints, the primary key and foreign key constraint, the easiest way to say that is that if you delete one record, because of those keys, it will delete all the associated records in all the tables. Or you could have it where you cannot delete any record in all across the tables, because what that does is that'll leave orphan data. And that's something for a more advanced database tutorial. But tables are linked together in a relational database to provide extra security and to lower storage, and you don't have redundant data. So you don't have the person's name 1,800 times with 1,800 transactions, let's say. That's how that works. So what we're going to do now is, this is our corrected file. We are going to go back over and we're going to open up this directory here. No, we're not. We're going to open up. Come on. I clicked on you. There we go. I knew you could do it. This directory here, we are going to go in my broken world, and we are going to take the maps file and put it in here. This is our damaged maps file. And so what we can do here is we can open up another terminal shell here. And I am lazy, so you will see me dragging and dropping. These are SQLite tools. This is the program SQLite 3. And we are going to hit enter. Hit enter on it. It's open. Working in the command line takes a little bit. It can be frustrating. There are great commands on the SQLite database here. Command line shell. It has these dot files, which I will show you. You can hit dot help and it will show you. So I want to open a file. So it says dot open file. Oh, okay. Well, that was easy. So it means that we're going to dot open, and the database file is map.sql. I don't want to type all that. And I'm using the terminal. So that's open. So we can do dot tables. And it shows that the tables are blocks. We could also select count row ID from blocks. And you see that number matches. That's a query. This right here is a query. I'm asking the database to do something for me. And I'm asking it to count the rows. That's all I want. And it gave me the count. So now what we are going to do is we are going to type pragma integrity underscore check colon or semicolon. And it's going to do its thing. And unfortunately, if you type something wrong, it won't give you an error. It'll just return a prompt, which is wrong. So we see the same error message that we saw in the GUI version, in the application version. So we are going to try VACUUM, vacuum, which I can't believe I spelled that correctly. And it's going to do its thing. Come on. It's still thinking. Come on. There we go. Should be done. So we are going to go back up. We are to do a integrity check, and now it's okay. That's all there is to it. Dot exit. And we are going to just close this one terminal out because we want the other one. So now that file is fixed. And that's basically it. So now what we are going to try to do again is, this is our working file. We're going to copy that back in to my broken world. And I want to see if it picks up the journal. So it should. And we are going to go in. Now, there's something interesting about this file here. You're going to see this fluctuate, which is kind of cool. Let's make sure it runs first, though. Come on. I'm running an awful lot of mods. You have to understand that my worlds are, because I run a Mac, there is no real theoretical stable version. And, well, you have to use a thing called Homebrew on a Mac. And I don't like using Homebrew all that much. So it took it. That journal completed. That transaction completed. Now notice how it keeps bouncing. It keeps opening up a journal file, closing a journal file. And it's going to do it again. It's going to open it and close it. That's things in the game. The game is running. It's running in server mode right now. And I'm going to boot it up real quick. There's my broken world, but we're going to play online because it's at localhost. So I'm running a server off my localhost, and it is a local server. And then I'm running a client, and I won't get any more of those out of memory. So it's kind of neat. So if you have a whole bunch of mods, and I do, trust me, I do. I have a whole bunch of mods. These are all my mods right here. Everything running, and Dream Builder has a whole bunch of mods in it. So that's what that is. And we'll go back to here to check this. Everything appears to be running very nicely. So how's everybody doing? It has been raining the last 2 days in Chicago, but it's okay because the flowers need it, and rain is cool sometimes. And it's been out of the 90s. It's been in the 70s and 80s. So we are having a good time. This is coming up. And it takes a long time for my version. You can see here I'm running 0.4.16 dev version. And when you have issues like this, you can't necessarily blame the mod or blame the game, because if you're running a dev version, that means it's not as stable as the quote stable version, which has been tested. So there are going to be a few things that you have to give up. So now you can see here, action. I joined the game on my host, local host. RGS Pro joins the game. Oh, this is real cool. So you notice how on the two Digtron videos, if you right click on like that head, you can't put another head. Well, on Mac, it's the sneak key. Lets you do that. Am I running in disabled? So you hit the sneak key, and anything with a menu, you hit the sneak key and right click, and it will put on top of there. So I just thought that was really cool to share. And what we are going to do real quickly is we're going to, now I don't know if this world has anything in it. Well, this is the world that you can see it lag a little bit. On my real world, I put a fountain over there, which I'll show in the next video. Wow, we are lagging a little bit. However, it's not as bad as it was. We're going to try to fly off the world here. I'm getting about 60 to 70 FPS, frames per second. Come on, you could do it. As soon as this pops in, we're almost done. Come on. There's a horsey. We're almost there. There we go. So there. But there you have it. We're going to put a battery box here, and we have no batteries. We have no batteries. I showed this in the last video, so this should be fine. And we come over here. We're going to put a battery box here. We don't have any batteries in it, but I'll show you that everything is working as intended. Look at that. And I saved the world. Now, if you saw the Digtron video, you'll know that the world was saved. I did save it, but now what you get to see is you get to see it live. Now let's go over here. Well, now the active blocks, anything that is an active block. Now you saw we didn't get those. Here's my underground base. You saw we did not get the active block error like we did in the other ones. So here's the factory. So all this Technics and pipework stuff, this is all running in the background. If we come down here, here's all my grinders and everything else. This stuff is all causing issues. Well, there's a blinky plant up here hidden. I have 3 quarries. I have nuclear vessels, as they would say. I have all these vehicle mods and everything else running. So whatever caused the game to crash, I don't know. And I can't really replicate it. As soon as everything loads in, it'll start acting much better. But there's our ship. All our mods are running. Got my tables and stuff back. Very nice. So that's how you do it. That's how you save. That is how you save. Now, notice there's no transaction. There's no map.sql.transaction. SQLite transaction file. Now, the world is still running, so there's stuff like spawning in the world, like plants, or trees are growing, or anything that changes a block, it constantly gets written into that database in the active block. And that's how that works. And now we close down. So that's how you do it. That's how you basically troubleshoot the database. All the information I'm going to put in the show notes on, if you're interested in the database, or if that was all, you're satisfied with knowing how that works. Now, every day at 6:30, my server shuts down. 6:30 a.m. it shuts down. It creates a couple variables, backup files where the worlds are. You cannot back up a database that's active. You will have a corrupted database unless you're using special tools from the vendor. And there is one with SQLite, which will allow you to back up a hot database. So, but I shut it down. I tell it where the backup files are, where the backups are going. It creates the archive. and then it compresses the archive in this format, and then it restarts my server. So all this information will be in the show notes and go from there. So that's basically the very, very, very basics of a database in terms of how Minetest is using it. And this world is no longer broken. It is fixed. This house is clean. Poltergeist. So yeah, hopefully this was informative. Not everybody is going to want to dive into working in databases, but if you are, there are a lot of free and open source programs out there. MySQL, Apache Derby, SQLite, HyperSQL, and that can get you started on digging into basic programming and database administration. Everything uses a database. Firefox, the browser, uses a database for all your bookmarks and history and settings and everything else. So every time you go on a website, chances are it's database driven. It's a data-driven database. So there. So hopefully this has helped out. In the next episode, I'm going to get back to building. Thank you very much for watching. If you have any tips on things that you found in errors in the Minetest world and how you fixed them, please share them with us in the comments. So again, until the next video, thank you for watching and goodbye.